Yeah, I hope on the screen is visible. Okay. So again, welcome back. Uh, Welcome back to the live video session. So this is regarding the week 2. So I'll be solving some of the problems which you have already gone through in your week 2 of structural analysis 1. So again, like for the new, maybe there are some students who joined for this week. So I am Prithvi. I am a research scholar from the civil engineering department from IIT Hyderabad. So you can, I have already provided my email IDs. Maybe if you have some doubts from the discussed from the session which we have discussed today, you can just write to me. So these are the topics which was covered for the week. Excuse me, someone is joining me. Yeah. So these are the topics which were covered for the week 2. You can see the method of so it's basically on the plane truss, mostly on the determinate truss analysis. So let us directly go. I just want to discuss some of the theory, for just first few minutes. So the main assumptions which we do for the truss design is usually what we actually assume is that the truss is it is actually a pin member. That's what we assume, right? First, initially that is what our first assumption is. So usually we say that all the members of the truss are connected by pins. So usually when compared to the beam, right? So beam usually it can also transfer. Let us say this is a fixed, this is a support, and it's a beam member. Let us say this is some beam. So what are the characteristics of the beam? Beam can take moment, it can take shear force, it can also take axial load. So there are axial loads coming, and also the shear force it can take, and also it can also transfer the bending moments. So that is actually that is how the beam is defined, right? So when it comes to the truss, usually the truss members are axial members only. That means it can only either take tension, or it can only either take compression. So that is how the truss members are defined. So in order to actually qualify this thing that it is only the axial member, usually we assume that more than assumption, even for the actual structures out there also, when you see a truss member, when you see a truss member, or when you see different types of trusses, so all these truss members are usually connected to each other as pin members, right? As pin members. So what are pins? So pins, at the pins, what can actually pin do? Pin can transfer the horizontal forces and also the vertical forces, but it cannot transfer the moments. Okay, if it is not able to transfer the moments, that means it can allow for rotation. It can rotate, but it will not allow the movement. So whatever the movements which are coming to that, there the movements are actually zeros. You'll not get any movement there. I mean, you'll not get any bend movement there. That's what I mean. And also in the truss, for the simplicity, we usually take the loadings acting at the joints. So why only at the joints? Why not on in any other places? So usually we'll take the loads acting at the joints only, at the joints. So what if the load acts here? If the load is acting here, right, that means you'll have some bending happening. But but as we discussed, the first point says that the members are connected by the pins, and also the truss member can only take axial load or the axial load, those are the compressive loads and also the tensile loads. So when the loads are acting on the members, when the loads are acting on, like, for if it is acting something like this, that means it is also carrying some of the transverse loads, and because of that it has to bend. But that is not how the truss is defined. So that is the reason why we usually take the loads acting at the joints. So that is one of the reason. And you might ask now, so let us say if there is a truss member, let us just say a triangular, this a simple truss. So there is a load acting on the, on one joint, on one joint. So you may ask me, what about the weight of this, right? There's also the self weight for this member, there's also the self weight for this member, and there's also self weight for this member. So the self weight usually it definitely acts as a, UDL. That's what we have studied, or that's what we know that. Just a second, someone joined. Yeah. So that's what we have studied, right? So we have the each member is having its own self weight. So because of the self weight, also usually we have that actually transmits, or that actually applies over the length of the, over the length, or over the volume of the section, or over the volume of the member. But even in that case, what usually we assume, so that what usually we assume is that half of this weight is transferred to this joint, and half of this weight is transferred to this joint. That is what we assume, for simplicity of, doing. So that what happens is that we kind of neglect the bending moments coming in the truss members, in these members. So as we define that truss can only transfer the axial loads, we usually also assume that the loadings are acting at the joints, so that our work will be easy, and also it's easy to find out what are the forces that are transferred in the truss members. Next, coming to, again, as we know, we have determinate structure and indeterminate structure. If is it stable, is it unstable? So for that, we again have this formula. So again, let us see how the formula was derived. So we have a truss member again. Let us say it is simply supported. Okay, this is simply supported. This is a truss member, and each member can have uh, either compressive load or either tensile load. So there are only two options for this, right? Either compression or tension. So each member can take two loads. So those are unknowns. We don't know what are those. So what are the unknowns? Unknowns are member loads. Okay, member loads, and we also have an external. So these are the supports, right? These are the support reactions. We can have one over here and one over here, and this is a roller support, so it cannot allow the vertical displacement of it. Even though this is a roller support, right? Maybe a displacement in this direction is restrained, but also you have to you should also pay attention. The displacement in this direction is also restrained. So even though it is drawn like this, you cannot have displacement in dip upward. It cannot lift up. That's what it means. It can only slide in this direction. It can only slide in this direction. It cannot lift up or it cannot go down. So member loads are, there are three member loads for this, and there are one more unknown. Those are reactions. So we have three reactions. Okay. Now coming to the number of equilibrium weeks. So these are unknowns. So we don't know this. So for it to be a statically determinate, for which we can use equilibrium equations, what yeah, yeah, this is a roller support. This is a roller support, so you will not have a reaction in this direction, right? Yeah, so there is only a reaction in this direction. You can have a reaction in only the vertical direction. So this is a roller support. Maybe you are comfortable with drawing in this way. This is also a roller support. So this is also a roller support. This is a pin support. Okay. Yeah. Okay. So there are three unknowns. three member loads which we don't know, three reactions which we don't know. We need to find it. But now coming to the equilibrium equations, right? So now right now I said each joint can have two different equations. Here the moments are already taken care. We don't have sigma m equal to 0 is not required because these are already hinges, right? So only things which we have is sigma fx that is equal to 0, sigma fy that is equal to 0. Each joint can have this. So each joint, it has to satisfy this equation. Sigma fx is equal to 0. In x direction the forces should be equilibrated, that means it has to be balanced, and in y direction also the forces has to be balanced. So how many joints we have? Three joints. So 3, and we have two equations, those are 6. So 3 plus 3 are unknowns, and we have 6 knowns, those are 6. 3 plus 3 minus 6 is 0. So this is a determinate structure. That means we can find out without any compatibility equations or without any other equations, we can simply find out. Just a moment, someone joined. Yeah, so without any other compatibility equations or without any extra equations, we can just constitute relations or something. We can simply find out. Okay, I didn't, sorry. So we can simply find out what is the what are the internal forces in this. So that's what it means. So for example, if for example, if you want to find whether it is stable or unstable, right? So if the degree of static indeterminacy is less than 0, then usually we call it as unstable. Okay, that means we have lesser unknowns but more the equation. That means there is some instability coming. And if ds is greater than 1 or 0, I mean if it is greater than 0, that is stable. We can say it is stable but indeterminate. We should have some extra equations also to calculate this. So this is one part. Next, let us solve some problems on finding out the determinacy and whether it is stable, and how to find out the stability of the truss members. So this is the first question. So you can see this is a truss, right? So this is a truss member. Like I said, choose the appropriate combination about the static indeterminacy and stability of the given truss. So let us say this is support A, this is support B, joint C and joint D. Okay. So we have 1, 2, 3 and 4 joints. So joints are pins, so that you should not forget. So these are 4 different joints, and we have two different supports, A and B support. So A is a just now other one of our student, he was asking me, so in this how many reactions are possible? Two reactions are possible, one vertical reaction, one horizontal reaction. So this is a pin support. So pin support will not allow movement in horizontal direction and will not allow the movement that means that you can't it can't allow the beam to actually move in this direction and in this direction. If it is not allowing, that means it is restraining, right? So that restraint is nothing but the forces coming on that support. And in this, it cannot allow the movement in vertical direction. It can simply slide in this way. So if it is sliding in that way, right, there is no restraint coming. So you will have a velocity, you have a deflection. If you have a deflection in horizontal direction, but it is not actually confining it, it's not restraining. That means you will not have any reaction forces coming there. So you have three different reactions. So let us actually follow that the equation which we tried last time. So this is degree of static indeterminacy is b plus r minus 2j. Just a second, someone just joined. I don't know how to allow everyone here directly. Yeah, fine. So you can see here. So b is actually the number of members, R is number of reactions, and we have J is number of joins. As simple as that, right? So let us say what is ds in this case. We have numbers. How many numbers? 1, 2, 3, 4, 5. 5 plus what is the reactions, unknown reactions, 3, minus 2 times joins are 1, 2, 3, 4. So 8 minus 8, 0. So we can easily find all the member reactions. For example, if I give a load like this, some p load like this, you can find all the reactions directly with the help of equilibrium equations. That's what it means. So the degree of static indeterminacy is 0. So it is determinate structure. So it is statically determinate. One thing we have found out, whether it is stable or not. Again, ds, if degree of static indeterminacy is less than 0, then it is unstable, right? So now you just okay, fine, let us just forget about this thing, that ds should be less than 0 or whatever it is. But you just find out here, you have a support reaction somewhere here, right? So this is a simply supported kind of a beam. So now for a simply supported beam, is it a stable is it a stable structure? Simply supported beam is a stable structure, right? So you have something like this, and you have a roller support here. You apply some load, it will just deflect. It will not uh, it will not deviate much, right? So it is a stable structure, so there is no problem with this. So externally it is stable. Now coming to the internal thing, let us say I have applied some load here. This is a hinge, this is a hinge, and this is a hinge, but it can take load in this direction also, right? It can take loads in this direction, and it can resist these loads. It can take loads in this direction. So you have what it can do is it can simply take the loads in this direction without any without any much sudden degree or sudden displacement of that joint or something. So at the same time, if you are trying to push this in this way, there are forces which are developed. So let us say if you have this in this direction, and there is one more here. So if you are trying to push in this way, let us say I'm applying force P, and you should also kind of mind that whenever I'm applying load, I'm applying at the joints. That's what we were discussing, right? On the truss members, usually at the joints we'll be applying the loads. So you can see when I'm pulling this in this direction, you'll have a reaction force uh, in this directions and in this direction. So that means ds is 0. I mean ds is equal to 0. It is not less than 0. So it is definitely stable. At the same time, physically also we can see it is a stable movement. So it is a stable structure. Okay. Fine with the first question. Can someone just unmute and say? Okay. Okay. Thank you. So let us go to the next one. This is again. This is not. This is again the truss members. We can see different types of trusses here. So we have three different sub questions in this. So let us say this is 2A, 2B, and 2C. Now we'll just go we'll just hurry up. So this is one. We have two different reactions. We have one reaction. This, you can see this is a roller support. This is a pin support. So let us go with this formula. What is that? B plus R minus 2J. Okay. So how many members we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 plus we have 3 minus 2 times how many joints? 1, 2, 3, 4, 5, 6, 7, 8. 16 minus 16, it is 0. So ds is equal to 0. So I want to ask one question. So when you have this crisscrossing like this, right? You have this crisscrossing members like this. You have a diagonal members which are crossed like this. So can I consider these two as two members or four members? One, two, three, four, or only one and two? Can someone unmute and tell me? Yes, yes, yeah, yeah, correct, correct. Yeah. Okay, yeah. Thank you. So yeah, like yes. So yes, the student he told me the correct like he was saying the correct explanation. For example, if you have a pin mentioned there, exact they will be mentioning it. If some pin is mentioned there, that means these are four members. But if nothing was mentioned there, that means they're just crossed. There are two members, those are crossed. So it is only two members. You should not count it as a joint here. Okay. And yeah, so now ds equal to 0, that means it is determinate. That's what it is meant, determinate. And it says it is stable because ds is equal to 1, ds is equal to 0. It is not, ds is not less than 0. But again, you just do some physical inspection here. Now what if I apply some load here, something like this, what if I'm applying a load in this direction? Okay, let us say not in that direction, in this direction and in this direction. So for a truss member, always remember it should actually form some triangles. Only then it can take all different types of loads. Okay. If a member is something like this, if the member is not braced, if the member is not braced, if you have some load in this direction, so you should know that these are the pin joints, right? So when you are doing in this direction, it will just collapse like this. It will just collapse like this. Okay, that if you have some member in this direction, when you are pushing in this way, it will offer some restraint here, it will offer some tension in this direction, or the compression in whatever the direction you are applying the external force, and then this collapse will not happen. But if there is no member in the diagonal direction, it will collapse. So if it is collapsing, right, even though, see, unstability is not that it is completely collapsing, or it is completely, it is coming, the structure completely coming down. Unstability is usually for a given load, if the displacements are zero, that means if there is, I mean, if the displacements are too huge, if the stiffness is very zero, let us say this is force and this is displacement. Okay. If you are for the entire structure, usually how it should, when you are applying some loads, the displacement should vary in this direction. But for an unstable structure, what happens, for a very slight load you will have a lot of displacements. For a very slight loads, you can see here, for a very smaller loads you have a lot of displacement. So if you have a lot of displacement, that means it is not stable. So the structure is simply just displacing, I mean, it is just deflecting when you just load it for a very minimal amount of load. So that means here the stiffness is higher, and here the stiffness is almost zero. Stiffness is almost zero. So if the stiffness is zero, then it is unstable. So in this so this question I have actually taken because I want to show even ds is equal to 0, you should always do physical inspection to understand whether it is stable or unstable. So these kind of structures are called externally stable. That means externally it is not going to move, but internally, internal, you can say these are the internal members. Internal members are trying to collapse or trying to be unstable. So it is externally stable but internally unstable. So this is one such example. Yeah, someone wants to speak. Yeah, yeah, yeah. BC. Okay. Yeah, 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 yeah. This one. Yeah. Correct. Yeah, yeah, correct. That's what I'm saying. See, you when you see this, right? When you see this kind of arrangement, you think that this is actually restraining it, right? You think that this is restraining. But when we see the stiffness plots, right? When we see these stiffness plots, when force versus displacement is plot against the displacement and force are plot against these things, right? You don't have in this direction. For example, let us take this point. So you have one member in this way and another member in this is, let us say this is a, yeah, this one C. Okay, this is C. So you have one in this direction and one in this direction. Okay, so what happens is that because of not having anything in this direction, right, these forces will become unstable, and you will have an what do you call resultant force in that direction, but it is not taking, this member is not taking. You understand, right? You are able to understand? Sorry. One at a time. Yeah. So you are able to find, you are able to understand this, right? This is an unstable. Are you able to appreciate that whether it is unstable? Correct. Yes. So correct. You are right. You are right. So let me. I'm opening a new page. Yeah. So okay, this is what the question is, right? Yeah. So this is joint C. This is I think E. Okay, so let us say, okay, now we have all the loads coming here. Let us say you have some load coming, some load coming here. Now when is this equilibrated? Like, you take this C from joint, you have C, and let us say this is B, this is C, you have E, you have forces coming in this direction and you have forces coming in this direction. So what we actually need is we need some forces to equilibrate, right? So these forces has to be in equilibrium. That is our one condition. All the forces, that is sigma fx should be 0 and sigma fy is equal to 0. This is one condition. This is the conditions of equilibrium. Now consider this joint. This is joint C. This is joint E. So we have this in this direction. We have forces in this direction, we have forces also developed in this direction. So now just tell me, what what about when you are trying to equilibrate all these forces? Let us say this is F1, F2, F3, F4. What happens is that if you don't have any other member in this direction to actually nullify this effect, you are able to understand it, right? If you don't have any member in this direction to nullify this F1's effect, F1 component of this is, what is that? F cos theta. That should be also equal to, let us say this is x cos theta plus F3, you have F4. So always remember, when you don't have this bracing coming, you have an extra force which is acting in that direction, but there is no member to take that force. If you have force but there is no member to take that, that means you have displacements. If you have displacement, those displacements are very large. For a given force, the displacement gets very large and this gets collapsed. You are able to understand? Yeah, yeah. Just a second. Someone joined. Just a minute. Yeah, yeah, yeah. You can tell me. Correct. Okay. Fine. That is not the. Yeah. Correct. Yeah. Correct. 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 So fine. That should actually see that should is valid in all. That should be valid in all the nodes, right? It should be valid in all the nodes. Can you try that once you see this? You are saying that maybe F3 magnitude will be more, right? Or F2 magnitude should be more because F2 in this direction it should have a higher magnitude, right? Okay, so yeah, you have some force coming in this direction, in this direction. You can see my arrow, this one. Okay, so in this direction, if you have some forces, right? If in this direction you have some forces, what if, for example, if you are applying some load here in this direction, or maybe you are applying in vertical direction, you should have some member to actually resist in this direction, right? DS will be, is it two or one? If there are two things, then it is B. It should be two. It should be two. If we have 15, right? 15 3 minus 2 into how much? 1 2 3 4 5 6 7 8. 18 minus 16. 2. Yeah. These are yeah, indeterminate. That's what. If indeterminate, but it is stable. I'm only discussing about the stability. Your doubt is clear. See, you can do one thing. You like again. I don't want to I don't want to extend this further, but you can do one thing. You just try to solve this question. See this one. You try to solve say the same question. You apply some loads and you try to equilibrate it. Okay, you apply with different types of at different joints. You try to apply it. You try to equilibrate. What are you like? Are you able to equilibrate the forces? It should be, for example, if you are considering this section. Okay, let us say you have considered this half of the section, and you also consider this half of the section, and you try to equilibrate. So both the halves, when you make, for example, at this joint, you should have the same force x here, and at this joint you should have the same force x, right? It should be the same. So you try to find out whether if it is same or not. In that way, I think you'll be getting more yes, yeah, more clarity. Usually the bracing usually takes the unbalanced load. Understand? That's why the truss should always have a bracing. The truss should be almost the triangles. It always takes the unbalanced load. Okay. Yeah. Okay. Yeah. So sorry. Yeah, please excuse me. Actually, someone is joining all in between. That's why I need to come back all the time. Yeah. Yeah. What about the second one? B. So B, we have again we have one pin, and this is a roller. So number of members are actually I have already solved it. So you can also see DS is already, number of members are 12, plus reactions are 3, and number of joins are 1 2 3 4 5 6 7 8. 12 times 3, sorry, 12 plus 3 is 15 minus 16 minus 1. One is joining. Yeah, students who are joining late, right? Please try to join, within 15 minutes or 10 minutes, because whenever I'm going back to the slides and coming back is always, it's kind of disturbing others also. Kindly plan to join in, like, within 10 minutes of our session starting. So in this DS is zero, DS is -1. So this is obvious, right? Yeah, like the other student, he asked me just now. So if you have some load here, it will already, there'll be, see, it might seem like it will not come, it will not completely collapse, but that's what I'm saying. If you apply some little load, you'll have a very big deflections. That's what this instability means. Okay. So here DS is -1, it is unstable. If it is unstable, there is no point of finding the indeterminacy. So there is no point of finding out the indeterminacy. So if it unstable, it is unstable. It's the structure itself. We are going to omit that structure wherever we are using it. Now coming to this C, how many members do we have? Again, let us say DS is equal to, we have 9 members plus. I hope you can count the members. I'm just writing it down. So we have three reactions. Joins, number of joins, 1, 2, 3, 4, 5, 6. 6 joins. 2 times 6. 9, 3 is 12 and 12. 0. So it is a stable structure, and it is statically determinate. We can have this degree of determinacy as 0, and we can find all the member forces and all the unknown reactions using equations of equilibrium. Okay. So this is about the second problem. So like, the sum the major take back from this second problem is, even though this formula says that it is stable and it is statically indeterminate, you should always have a physical inspection while you are actually assessing whether it is stable or not. Okay, and maybe that physical inspection, usually you get it through the experience. If you saw a lot of problems, you'll try to understand why is it required. And this bracing problem, like I said, maybe you can go back and you can try without that bracing what happens. You just see what is going to happen. So let us go to the third question. I hope so far it is fine for every one of you. I hope it is okay for you, right? Okay, thank you. Yeah, coming to the third question, now we have the again, you need to find out the forces in member AD. So this is what it was asked, and the diagonal members are not connected. See, the diagonal members are not connected. They have they have mentioned it exclusively. If they are not mentioning it also, diagonal members are not connected. We need to assume that there is no pin here. That's what we have to assume. If they say that there is a pin support, they'll definitely mention pin joint or something like this here, and they'll also mention uh, they'll also mention the joint number also, or the joint, which kind of a joint it is. So right now there is no joint here. So uh, students can start working along with me. You can just tell me what is the answer also. So I already worked out, but you can also start working. I'll also start working along with you. So you have this truss member. These are the joints. So this is A, B, C, D, and E. Again, like we already discussed, the loads are only acting at the joints, so that has to be uh, that should be clear. So the loads are acting at the joints. So what is A? So sorry, this is a roller support. So first tell me what is DS. DS is B plus R minus 2J. So how many members? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 7 plus reactions. We have simply supported kind of a reaction. We have a hinge support and we have a roller support. So we'll have three reactions: this direction and this direction, and in this direction. So we have three reactions, and number of joints are 1, 2, 3, 4, 5. So this is not a joint, only 5 we have. 10 minus 10, 0. So static indeterminacy is nil. So it is static determinate. So now, yeah, can you find out what is, okay, I'll just name it as horizontal at A, vertical at A, horizontal at E. Yeah, can you find out what are the horizontal reactions? So reactions actually, yeah, in this question, uh, we can find out the reactions, and we can actually make that joint equilibrium, and then we can find out what is the forces in AD. Okay, that is one thing. So first initially let us find out the horizontal reaction. What are the reactions here? So what I'll do is, I don't know, like, I want to find uh, let us say HA first. So HA times 3. Did anyone answer already? If someone is answering, you just it's better that you unmute and let me know. Okay. No, if you answer it right, I'll try to speed up my calculations. That's why. That's it. This is HA times 3, and this is 8 times. So we have again 3. That's it, right? So HA is 8 kilonewtons in this direction. So actually, this is rotating in this direction. This is actually rotating this pin in this direction, and this is rotating in this direction. But it has to rotate in this direction, right? So HA is this thing. And what about HE? So if HA is in this direction, so HE should be, this is 8 kilonewton. HE, it should be in this direction, 8 kilonewton, because sigma Fx of the whole system should be 0. So only X which is acting is HA. So this should be 8 kilonewtons. And easy to find VA also. So in this direction, the VA should be 0. VA should be 8 kilonewtons, because sigma Fy is equal to 0. Only vertical force acting is 8 kilonewtons, so VA should be 8 kilonewtons. So it is it right? Oh, there is one more load here. Sorry. Yeah, there's one more load here. So how much it will be? 8 times 3 plus 8 times 6 divided by 3. 24, 48 by 3. How much is it? 22.66 tensile. Yeah, I think, I think that's the right answer. Yeah, even I was getting the same thing. It is 16 root 2, right? 16 root 2. Yeah, okay. Fine. Yeah, for the rest of the students, I'm just telling this. So H HA, how much is HA? Can you please tell me what are the HA and HVA and HE values? Yeah, okay. And this is 16 kilonewtons, right? Yeah. Guys, actually, please mind, I didn't consider this 8 kilonewtons before. So now I'm considering it. So this should be like 24. Okay. So VA is actually direct, right? VA you can directly find out. VA is 8 plus 8, that is 16. There's only one vertical reaction here. So HA should be in this direction. It is 24. It is 24. Now how do you find this? So this is very easy. Now take this joint A. You have force in this direction, which is force in member AB, and you have force in this direction. There is force in member AD. So this is 24, and this is 16. So now this is easy to find, right? We need to just balance the forces. So can someone say when can we say that the forces in the members are tensile or compressive? How to denote whether the forces in the member are compressive or tensile? We have the forces in the members, or correct? Yeah, depends on the sign. But how do we come, how do we come along with the plus or minus sign? How can we say that? So yeah, yeah, that during analysis we'll be doing it, but how can we say it is, see, okay, now let me say, now we are saying I'm just pulling this thing in this direction, right? So is this tension or compression? So this is tension, right? So so usually what happens, so if I'm denoting something like this, right, even though it is showing it as compression, if you say that, if you are just looking at this joint, it is you can see that it is, I'm kind of compressing this, but actually what's happening is, let us say this is my joint. Okay, so what happens here, the reaction actually pulls in this direction. Let us say this is another joint, I'm pulling the joint in this direction. What happens here, the reaction actually pulls in this direction. So that means the member is getting pulled, the member is getting pulled. Okay, so most of the students usually get confused in this, that's why I want to just mention this. So when you're pulling the joint, that means it is tension. When you're pushing the joint, that means it's compression. Okay, this is how the free body is drawn, right? I'm just trying to explain it again. So let us say this is point A, this is joint B. If the joint is actually pulled in this direction, if the joint is pulled in this direction, now what I'll do is I'll just cut this joint. So I have a point here, and I have a member here, I have a joint here. So this joint is getting pulled. So if I cut here, it should also have in the opposite direction. This joint is getting pulled. If I cut here, it should have an opposite direction. Actually, the member is getting pulled. Okay, so that's why there is tensile load coming in the member. So did you find out what is FAD by now? FAD. So it is simple. FAD cos times whatever this theta, that is cos 45 plus, okay, this is okay. If I do this theta, what happens is that FAD plus FAB is equal to 24. I don't know FAB also. Now I to make my life easy, just a second. Yeah, to make stuff easy, right? What I'll do is, this is 24, this is FAB, this is 16. Someone actually, his mic is muted, I think. Can you please unmute it? FAD. So what I'll do is I'll take Fy, sigma Fy at this joint 0. So this will be FAB. Let us say if this is theta, this is FAB sine theta. In this sine, it is 45 degrees, so it doesn't matter. So FAB is equal to 16. FAB square root of 2 is 16. Sorry, it is FAD, I think. FAD. FAD is equal to 16 square root of 2. How much is this? 22.6. 22.6 kilonewtons. The sign is positive. See, at the end we got the answer as positive 16 root 2. That means it is in tension. I hope this problem is clear to everyone. If someone is having doubt, please ask me now. Anybody is having any doubt in this? Simple question, right? Yeah. Okay, I'm going for this next question. So find the number of zero force members or the null members in the following truss. So this is more of a logic based, right? So no need to actually analyze it. This is more of a logical kind of a question. You need to understand by the logic. Okay. So let us just simply solve this. We'll have reactions in this direction. We have reactions in this direction. So these are the reactions which are coming because of the load P. Okay, and this is determinate, so I don't want to start finding out the indeterminate. So this is a determinate truss. You can also verify this. This is a determinate truss. So you have load P here, and you have all these members. So now For there is no load here, right? Go by each member. So now let us actually inspect this joint. Let us inspect this joint. This is M. Okay, this joint. Now what happens in this joint? We have forces coming. This is FMO and this is FMI. So usually at the joint you have different members coming. So all the members we assume it to be in tensile initially, and then we'll analyze it for that, and then further we'll see whether the loads which we have taken are in the right direction or not. So, and we have another load coming in this direction. And please mind, this is actually a perpendicular. This is a perpendicular. Both are actually. Excuse me. Someone wants to stop? Yeah. Okay. So this is perpendicular. Now, just simply by just by simple inspection, we can say that. Let us say this is in this direction. So in that direction, the forces should be zero. I call this as x. Now in this question, I call this as x. I call this as y. X y. Sigma fx equal to zero. That is fine. We can do it. Sigma fy equal to zero. But I don't have any load in this direction, right? So there is only one f mj. In this direction, there is no external load or any member connected to that. That means fmj plus there is no load here, so 0 is 0. So fmj should be 0. Okay. So one point which you need to always remember is that, for example, there are two different members connected right angle to each other, and there is no load acting at this point. There is no load acting at this point. Then this member will not undergo any force. So the force in this member is 0. I hope this is clear. So in that in that direction, let us inspect for ij. So now this is gone. So just assume that there is no member here. There is no member here. Again, this is something like this. You have forces in this direction. You have forces in this direction. Okay. And there is a force in this direction. So now what happens is that this is now inclined. Okay. Now what I'll do is I'll have a in this direction and you have in this direction. I mean, let us say this is Fij, Fij, and this is Foj, and this is Fjc. So I'll just try to find this component. This is Fij. I read it as component in y direction, and the component of this is in Fij in x direction. This is that component. Okay. Now when you do this equilibrium, right, when you are trying to balance the forces, fjc plus fij x component plus foj is equal to 0. This you can do because there are three unknowns. Fine, that is fine, you can do that. When it comes to y, in y direction, you have fij in y direction, only this one in y direction, and there is no other force here. There is no force acting in this direction. 0 is 0. So fij in y direction is 0. So this, if this component is 0, okay, then this should be 0 because there is some theta existing, right? There is some theta existing. So fij y is nothing but fij some, let us say some cos theta or something. So if this is 0, cos theta can be 0 only when theta is 90 degrees, but there is some theta here. There is some theta here. So fij should be 0. So there is no force in this member also. Okay. So meanwhile, you can also do the same thing for this by inspection. This member is also having 0 force. Okay. And what are the other members? If this is 0, that means there is no member here, and you have a member in this direction, and there is one member coming vertical in this direction. So you can have forces in this direction, which can be equilibrated, but you should have, if you have, For example, if there is some forces in this direction, there should be some external load acting here to equilibrate it, but there is no external force. That means this member is also zero. And if this is zero, this is gone, this is gone, this is not there, this is not there. Again, this is something like this. You have in this direction. So whole for this member, you have only this member now. So this is in this direction, and you have this is perpendicular. So there is no force in this member also. Fine. And now all these braces are gone. All these braces, there's no reactions, or sorry, there is no forces in these members. So now we only have this triangle. Now we only have this triangle, except this braces. So we have this member like this, okay, and we have one member, and there's one more member here. So we have two members here. So obviously there is no load in these members also, because are you able to follow? Are you able to follow this, or shall I explain again? Yeah. So again, all these members are zero, and then you only have this member. You again, this is with some angle. That means this is also zero. So these are two members. So one, and this is also zero. Fine. Let us come in this direction now. There is some load here, right? You have one load. Let us say whatever we have, we have just formulated, whether it is correct or not. This is how it is. So this is joint N. To the joint N, there is some load acting. Okay, this is at some angle, 2p or something. So you have some loads here. There is some load here acting, right? So there should be some reaction coming in this. So you can't say this is zero. This is not zero. Yeah. B. Yeah, BC. Yeah, okay. I, I can understand you. 1 second. I'll just create another this thing that should be easy for you. Just a minute. Yeah, this is clear, right? Now it is clear. Yeah, yeah. Please ask. Yeah. Correct, correct. So true, true. Right, right. You're right. You're right. See, now you can accept that this is zero, this is zero, this is zero, and this is zero, this is zero, right? Can you accept that? Yeah. So now that those are zeros, now that means you don't have these members now. Now at this joint, okay, let us consider this joint C, this joint C. So at that joint, what happens is that, let us consider this is okay. There is B here. Fine. Okay, this is joint C. Let us say this is joint C. So this is FCB, okay, and this is FCR, and let us say this, sorry, I can't- yeah. So let us say this is FCJ or whatever it is, CFJ or something. Let us say this is FCJ. Okay. So now you can see that, right? In this direction, there is no external forces. So this should be zero. And your question for your to answer your question here, when I say this is zero, right? Because of this P loads, the other members will take those loads. I'm not saying that this is zero. This should be zero because at this joint there is no force in this. And next time I'll also say that this is also zero because there is no at this joint also the vertical equilibrium should be satisfied. So this P load will be taken by only this member, and this member only. You are able to follow this? See, you are right. In your question is right. At this point, there is external load, but at the so usually in truss member at every joint the equilibrium equation should be satisfied. It's not that it only the loading joint or something. So when you say that at this point it has to be there, but in this point it is not validating. It's not actually having that equilibrium satisfied. So that is the reason why in that this member will not have any load. Okay. Yeah. Yeah. Okay. Yeah. Right. You are right. Correct. 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 Yes. Correct. Correct. Absolutely right. You are right. If this is not satisfied, this member will keep going in this direction. Okay, if for example if Fi is not 0, that means there is some extra forces coming in, that is unbalanced force, that means this member keeps moving in this direction. Okay. Fine. Yeah. Thanks for asking that question. So next, yeah, similarly, in this direction you can't say, because in this direction you have PE load coming. So this components may balance this load. So you can't say this is zero. You will definitely have some load in that. So in that, by inspection you can say this is zero again, because there is no external load. You have two forces coming in this direction, but in this direction there is no external load. So this member will have zero. If this is zero, that means you just assume there is no member here, and this will be zero again. And anything else? So how many we have done already? 1 2 3 4 5 6 7. This is 8 9 and 10. Yeah, I think 10 members are non-zero members. If you inspect for the others also, like, just we'll inspect for other members also for the case of completion. Now in this member, what happens in this member? You already have some forces here, so you will definitely have some forces here. You can't say this is zero. Okay. And in this also you can't say it is zero, because you have all these members connected. These are non-zero, these are non-zero, sorry, these are zero, but these are non-zero. So you'll have some balancing force coming in this. Even in this direction you'll have some forces coming in. I hope this is clear. Everyone are able to understand that why we are having zero forces in the members. This is just a logic based. You have to just apply some kind of a logic in this. No need to analyze everything and find out. You can just simply say, if the components are zero, that means the actual force or the resultant force is zero. Because unless again the theta should not be 90 degrees or 0 degrees, whatever it is. Okay. Let us solve the other question. I hope this question is fine for everyone. Yeah, you can just message me or just say okay. Okay, thank you. So let us go for the next one. In this question, I think this is question 5. Find the force in member BE CE due to the load 8 kilonewtons. So this you can use whatever method, like whatever method you are comfortable with. If it is a what is it, method of sections, you need to cut the section. Um, and if it is a giant, like what is it, method of the joints. So usually the joint you will do this force equilibrium, which we were doing for the last two questions. So you try solving along with me. So you have this thing here. Yeah, this is here something like this. So this is 60 degree. This is 4. This is 4. And if this is 60, this is also 4. This is also 4. So it's kind of an equilateral triangle. Okay. So what are the reactions? First find out the reactions. What it was asked? Yeah, B. Okay, the forces in member BE and CE. BE and CE. Fine. Yeah, you can keep solving this. I'll also solve along with you. Let us take this. So now, what are the reactions you're getting? So reaction forces, let us first solve the reaction forces. What are the two reactions we have in this direction and in this direction? Let us say this is vertical A, horizontal A, and this is vertical E. So let us take the moment about this point, 8 times 8. Okay, that should be balanced by VE times 4. So VE is having 16 kilonewtons, and yeah, if this is 16, VA should be known. Sigma Fy is on the whole system should be 0. So VE plus VA should be 8. VA, so VA is actually vertical reaction in at A joint A minus 16. So this is minus 8 kilonewtons. So now it is in this direction. This is 8. So all are in kilonewtons. What about horizontal force? Do we have any horizontal force here? I don't think so, right? Because there is no forces coming on the structure. So if there is no force in, I'll just solve that also. Fx is 0. So only HA is in horizontal direction. There is nothing else. So HA is equal to 0. So this is 0. So what do we do about BE? So let us take this point. So in this direction we have 1, 2, 3 and 4. 4 unknowns. So this is not suitable initially, right? So let us solve what do you want? FCE. What is FCE? Yeah, FCE is in this direction. Either you can solve by using method of joints. You can consider each joint. For example, I'll just tell you at joint A. Let us say this is A. You have load coming in this direction. You have forces in this direction, and VA is in this direction 8 kilonewtons, and HA is 0. This is FAB, and this is FAE. I'm sorry, again someone just joined. I don't know. Someone must. Yeah, Dinesh, it's better you join a little early. Yeah, okay, please, because in the middle, if you're joining, it is actually creating some disturbance. Okay, next time onwards, please try to join within 5-10 minutes before we start the session. Yeah, thank you. So this is how we find out. Again, there are two unknowns. We have two equations, sigma fx equal to 0, we have sigma fy equal to 0. So FAE, you have the components, right? We have different components in this direction. So FAE has component, now like let us say FAB. So this is FAB. So what is this? This is 30 degrees. So FAB times cos 30 is 8. FAB is 8, cos 30 is how much? 2 by root 3. 16 by root 3. 16 by root 3. Similarly, f in x direction. Now what I'll do is sigma, this is sigma fy equal to 0. Now sigma fx equal to 0. Fab times cos 60 plus FAE is equal to 0. So FAB is already, cos 60 is half, FAE that is 0. FAE is minus 8 by root 3 kilonewtons. So this is one way of finding out. So now in this, what we have found out? We have found out this reaction. So this reaction also can be found out by taking the fx equal to 0 and sigma fy equal to 0 at this joint. So there is one more very easy method in this. By just inspection we can say that. I think you might have learned about the method of sections, right? So you just cut this section here like this. Okay. So now what are the forces you have on the left hand? You have these forces. You have one force like this. You have one other force like this. And this force like this. And you have one force in this direction. So this is 8 kilonewtons. This is F. What is this? FDE. And this is FCE. And this is FCB. Okay. Now we want to find out what is FCE only, right? So one easy way is, um, let us say, okay, these FCE CE member and D member are joining over here, right? At this point, at some point, what is this point? This is E point. So let us take, uh, okay, instead of taking, okay, fine. Instead of taking moment about this point, what I'll do is, I'll simply say Fy in y direction. I'll just take the equilibrium. In y direction, I'll just equilibrate the forces. So what are the forces in y direction? We have 8 that is in minus, which is downwards. 8 is in downward direction, and FCE is also in downwards direction only. FCE, this is theta. This is 30 degrees, right? FCE cos 30 degrees is equal to 0. So FCE is equal to 8 cos 30 is 8 times 2 root 3, 16 by root 3. Okay, what is 16 by root 3? I think it is 9.2. Now 16 by root 3 we got it. Initially we assumed as tension, but we are getting it as negative because FCE is minus 8 by, so we are getting it as negative. That means it is in compression. FCE is in compression. So how do we denote in compression? This is how we denote it as compression. FCE member is in compression. So CE 9.2 in compression. Okay, 9.2 in compression. There are two options, B and D. So what about BE? So BE also, you what you'll do is you just cut this section here. Okay, cut that section there, and then just equilibrate this. You have, sorry, I'll use another page. Sorry. Okay, what I'll do is I'll just simply cut the section here. Okay, now what I'll have, one this direction, this direction, this one, and in this direction. So what is horizontal reaction at A? It is 8 in the downward direction, right? 8 in the downward direction. So this is 8 kilonewtons. So this is FAE. I'm not concerned about this. FBE is what I need to find. FBC is what I have to. That is also not the matter of concern. So again, what I'll do is in this, I'll take Fy is 0. In y direction, I'll try to equilibrate. So this is in x direction, this is in x direction. The component of these forces are 0 in y direction, right? So FBE cos 30 again. So this is 30 is equal to minus 8. Both are in the same direction. FBE is again, how much is that? 8 into twice 2 by root 3. Yeah. So 16 by root 3. This is again 9.2 kilonewtons compression. Okay. So the option is D, 9.2 compression and 9.2 compression. So sometimes method of section becomes very easy. You can see in this case, you can simply find out the forces in the member by just cutting the section and then finding out and then doing the force equilibrium and then finding out the forces in the members. So this question is all right for you. I hope this question is clear. I'm going to the next question. Yeah, this is the next question. Yeah. Okay, thank you. So this is the next question. Determine the forces. So right now we already have a very good hands-on on different types of solving the truss question. So now I'll just go a little. I'll go in a little. I'll try to calculate in a little faster way. So I hope you can catch up. If I'm going very fast, you just let me know. Okay. So let us find out what is the whether it is statically determinate or not. First, b plus r minus 2j, and also internally inspection. We have done the internal inspection. All the members are triangles, kind of a triangles. So there are bracings provided. So internally it is not. There is no problem with the stability. B plus r minus j. So b, this should be 0. So ds is 0. So this is determinate. So this is determinate. So this is, let us take CH and CF. What is CH? Okay, this is the CH, remember. And what is CF? This is CF. Okay, now fine. Let us find out the reaction forces. So what will be the reaction forces? This by just visual inspection, you can simply say what are the vertical forces. See, here you can say the member is symmetric. First of all, that is fine. It is symmetric, and also the loads are also symmetric. You can say 20, 40, 20, right? So the loads are symmetric. You just cut half section here. So this is almost symmetric. It's almost the symmetric in the what I mean is it's a mirror image. So what should be the load? So 40, 20, 20, how many? 80. So it should be 40, 40 here, and it should resist 40 here, just by the visual inspection. Even if you do the moment calculation, if you take moments about point A or point E and then you calculate, you'll get the same thing. And there is no horizontal reaction, so you will not have any horizontal. This force is zero here. There is no horizontal forces, or there is no horizontal loads applied here. Okay, on the truss member. Now, how do you find this? So one way is directly finding, again you're taking this thing, cutting this section and then finding out CF and CE. So let us anyways, we have already done method of sections, right? So in this we'll do this joint method of joints. Previously, if I said, right, I think the last one of the like one of the students, he was asking me this question, right? So here, same thing, you have horizontal component, you have a vertical component here, but in this you also have a vertical load here, right? So this load you can directly say by the inspection it is 20 kilonewtons, because it has to balance this load. It is directly 20. You by just by visual inspection you can just simply say that uh, it has to be balanced. So that is the only possible way, because taking complete load by the member itself. And then you have 40 in this way. So let us take A. This is joint A. So this is FAF, force in AF, and this is F. What is this? AB, and you have this is the support reaction 40 kilonewtons. So what I'll do is FAF. What is this theta? This theta is already known. This is span at 4. So this is 4, 4, 4, 4 meters, and this is also 4 meters. This is also 4 meters, and this is also 4 meters. Okay, so AF, this is 45, 4 and 4, right? This is 4 and this is 4. So this is 45 degrees. That's what it means. This is 4 and this is 4. So this should be 45 degrees, and this is also 45 degrees. So FAF cos 45 plus 40 is equal to 0. FAF is equal to minus 40 root 2. So in this FAF we have a compression coming, and also if this is compression, right? So you have compression coming in this direction. So now in x direction, FAB plus FAF, this is 45. Cos 45 is equal to 0. FAF is already minus 40 root 2. Cos 45 is root 2, and this is 0. FAB is plus 40 kilonewtons. So this is 40. Okay. Now this is 40, and this should be 40 again. Okay. So if this is 40, now how do you find F? What is this? Yeah. How do yeah, this is 40. Now as I said, this is a symmetric section, right? So the same thing is happening here also. So this is again how much is this? 40 root 2 compression. This is again 40. So again this should be 40 again. Okay. Now. So now we have 1, 2, 3, three unknowns, right? So we have three unknowns, and we also know this thing. So from here you can find out from this joint. You know this. You know this. There are only two unknowns. One this one and one this one. So let us say joint F. So joint F is having 40 root 2 force in this direction. This is unknown. Let us say this is FH. uh, this is unknown, and this is 20 kilonewtons. So now uh, this we already have it. Now what you'll do is, let us take this as complete this as in one direction, and these are in other directions. So F 45, everything is 45. So the angles are 45, because the question is so simple that everything, the question in the question, the angles are with the horizontal and with vertical, it's 45 degrees. So what can we do in this? So now this is again having two different equations. So we have F FC, and this is F FH. So F FC cos 45, in the I'm taking sigma Fy equal to 0, okay, plus 20, okay, uh, down here I'm considering downwards as positive, plus 20, okay. Now we have FH in the upward direction, FH cos 45, minus we also have this in upward direction, so minus 40 root 2 cos 45, that is 0. So this is one equation. Now we also have sigma fx is equal to 0. Fine. So sigma fx equal to 0. In that, what will be doing in sigma fx equal to 0? So f fc cos 45 plus f fh cos 45. So I am using cos 45, sin 45, interchangeably, because of the angle being 45. Otherwise we should be careful in using cos and sin, wherever it is properly mentioned, right? So anyways, so yeah, in this direction I mentioned. So ffc cos 45, ffh cos 45, and 20 does not have any horizontal component, because it itself is a vertical force, and 40 root 2 also in right direction, in right side towards right, 40 root 2 cos 45, that is 0. This is equation 2. If you solve these equations, right, equation 1, yeah, equation 1 and equation 2, if you solve this, you can find out ffc and f, what is the other one? What is the other one? FFH. So FFC, I already solved it. I'm getting about how much is this? T FFC CF. That's what. So this 14.1 kilonewtons compression. So I got FFC as minus 14.1 kilonewtons compression. Can you try, or shall I solve that also? I think it's two variables, two equations. Correct. Yeah. Answer is D. Yeah. So so this you can solve, right? 14.1 is you can solve directly. This is I think you will be getting around 20 by root 2, something like that, 20 cos theta. So I think 20 by root 2. This should be 14.1 compression. So if this is let us say this is 14.1, so this should be 14.1, because this is symmetric. If this is symmetric, the only thing is you need to find out is the forces in this member. So in this member, I'm taking this joint C. What's happening at joint C? Joint C, you have an external load of 40 kilonewtons. You have a compression coming from this, that is 14.2. You have a compression coming from this, that is 14.2. And this is what we need to find out, that is FCH. Okay. And you have compression coming from this and compression coming from this. This is 40 and this is 40. So yeah, so how do you find FCH? FCH. Let us take sigma fy equal to 0 at that joint. Sigma fy equal to 0. Fch is equal to, sorry, Fch, I'm taking upwards as positive, minus 40. You have 40 in this direction. So these 40s are not considered. These are in horizontal direction. You have minus 2 times 14.2 into 1 by root 2, something like that. So that is equal to 0. Fch minus 40 minus 2 times this 14 by root 2 is 14.2 is actually 20 by root 2. So root 2 this goes off, and Fch is equal to 60 kilonewtons. 60 we are getting it as positive, so that's why it is tensile. Answer is D. Okay, any doubts in this question? Again, this is a case. The reason why I have taken this question is, it's if you can find that this structure is symmetric, right? So if you analyze the half of the structure, the other half will directly be the replica of it. Okay, I'm going to the next question. So let us solve this. This is again the similar question. Let us solve this maybe a moment later. I just want to solve these two questions first. Okay, let me solve this question. This is seventh question. So again, you have all these members. It's a truss member. Now find out the force in the question. Sorry, I forgot. Find out the force in FHI. What are the forces in FHI? Again, one type of solving this problem is you need to find out all these support reactions, and then you need to do this force equilibrium at each joint. At each joint you need to do, and then you can find out. That is one type. The other one is method of sections. So in this, luckily you don't have any supports in the right direction, right? So there is nothing which is there in the right, in this direction. So what I'll do is I'll simply cut this section in this wherever I want. I'll just cut this section here, okay, and then I'll find out this. Okay, this is E, D, C, and this is I, and this is J. This is K is actually kilo pounds. This I've taken this example. I have taken it from some book actually that was having all these what do you call, the pounds, FPS kind of system, foot pounds and second system, FPS system. So just find out what are the forces. So K means kilo pounds. That's what it says, kilo pounds. So this is 25. This is 25. This is 25. Okay. So 25 kilos. That's what it means. So if I cut in this cut this section here, this is FHI, and this is FCH, and this is FCB. Okay. Now I want to find out what is the force in FHI. What I can do is I can simply take moment at this point. I have three unknowns, right? FCH, FCB, and FHI are my unknowns. So what I'll do is I'll simply take the moment about this point as 0. So you can keep trying. So moment about this point is 0. Sigma m at c is equal to 0. So 25 into 25 multiplied by, what is this, 1, 2, 3. So 20 feet apart. 20, 20, 20, and 20. So this 25 into 40 plus 25, this 25 into 20. Okay, and you have 30. This is also rotating in this direction. This is also actually rotating the joint C in this direction. So that is plus 30 into 15. Okay, And now what's happening with FHI? Minus FHI into 15. So FHI is actually counter rotating. These all, if for example, if these are rotating, trying to rotate the joint C in clockwise direction, FHI is trying to rotate in anti-clockwise direction. So that's why I used minus there. That is 0. FHI is equal to, how much is this? 25. I think I didn't solve. Yeah, okay. 40 plus 25 times 20 plus 450 divided by 15, 130. Yeah. So this question actually, you can see directly if the force in the member HI is asked, you can simply cut the section there, method of sections. You can apply the method of sections, and you can simplify. And in this, and also you have to mind that for these questions, I'm not. It's not mentioned that you have to use the method of sections or method of joints or something. So in your university examinations, maybe I think the professor will be asking you to solve that particular problem in method of joints or something. So this, for example, if the same question is asked to do by method of joints, so you need to keep going from each joint onwards, and you need to keep traveling, transversing with each joint, and then finding out the member forces, finding out the member forces. And this kind of approach, or for example, this kind of, right now we have used method of sections to just kind of verify. For example, if you are doing the same question using method of joints, you can take 1 more minute, or maybe a half a minute, to simply verify whether your forces are correct or not. That is the reason why I have taken this question. So that is how. So simply, in other way, you can also find out FCH. FCH is simply, if you balance these forces, you directly get FCH. And FCB is directly, FHI, and you have 30. So FHI is 130 in this direction and 30 in this direction. So FCB will be 100 in this direction. Okay. Can I go to the next question? Everyone is getting this 130 kilo pounds, right? Actually, I didn't solve this question before. 20, 25. The calculations are correct, right? Yeah. Shall I go to the next question? Fine. Okay. So this is the this is one more question which I felt it is kind of interesting. So there is a very simple truss, triangular truss. Uh, Out of the following options, determine maximum value of angle theta. So what should be the angle between each member, so that the maximum tension force will not exceed 2p. So tension force. So it is mentioning that the tension should not exceed. That means should not be greater than 2p, or else less than 2p. And the maximum compression force will not exceed. So it should be p again in the following truss if P load is applied at point C. So maybe you'll be learning about this design of steel members. Maybe you might have heard about buckling, right? Have you studied about buckling problem? I hope you might have studied that. For example, if a member, sorry, this is, yeah. So someone want to say something? Uh, can you please unmute? Uh, Vidya ji, can you please unmute your microphone? Yeah, thank you. So usually buckling, when you have a compression force acting here, this member buckles after some point of time, after some load, right? So that is the reason why the compression should not exceed P. That's what it is saying. The tensile forces are 2P. Maybe that is one of the reason which this question was asked. The maximum tension it can take is 2P, and the compression is P. That's what it was asked. So anyways, that is not what we actually want. We want to solve this truss here. So let us take this point. Okay, now if I take this point, uh, you have these members, right? So let us do this method of joins analysis. So you have this P. Okay, if this is P, what do you call this? Let us say this is FCA and this is FCB. Okay, now we have this as something like this. So if this is theta, right? I mean, if this is theta, then this should be theta. Okay, and if this is theta, and then this is theta. Okay, so FCA, what I'll do is I'll take Fy as 0 and summation of Fx as 0. Now first taking Fy in y direction as 0, cos theta, this is theta. Upward, I'm taking upwards as positive again, minus P minus FCB, again this is theta, cos theta. The thetas are same, that's what it's mentioned. FCA is equal to P plus FCB, sorry, FCA cos theta, FCB cos theta. Let us say this is equation 1. Now let us write Fx equal to 0. Now what is Fx? So when it comes to Fx equal to 0, FCA minus, I'm taking leftwards as negative, FCA sine theta minus FCB sine theta equal to 0. From this what we get? FCA is equal to minus FCB. Whatever the theta is, it should be valid. You know, if FCA is in tension, or if FC, let us see what happens. But if FCA is in tension, FCB should be in compression. If FCB in compression, FCA should be in tension. Okay. Now let us substitute this in the above equation. What is FCA? It is, I'll take FCA as it is, FCA cos theta, that is equal to P, and FCB is minus FCA cos theta. So FC 2FCA cos theta is P. Fine. So FCA cos theta is P by, sorry, FCA is 2 cos theta. FCA is P by 2 cos theta. So FCA is actually tension. This is positive, right? So actually there is a positive tensile force in FCA. And what about in FCB? It should be compressive because FCA is minus FCB, right? So FCB is minus P by 2 cos theta. So we have found out uh, what are the forces coming in two members, FCA and FCB. Now what about the third member? This is the third member, right? So what happens in the third member? Uh, now let us directly find out uh, what are the reaction forces coming here. So you have this in this direction. This is P, okay, because you have to have sigma Fy satisfied in all the directions. So you have P here. You have P should be in this direction. I'm not worried about this this force for time being. Okay, for time being, I'm not worried about this. Let us take this joint A. Let us take this joint A. So you have a force FAC now. Okay, FAC, and you have a force FAB, and also you have support reaction P in this direction, and this is theta. Now what I'll do is sigma Fy is 0. That is the reason why I'm not taking this. See, this I have to find it out. Right now I don't want to find it out because I only want to find out what is FAB. That's why I'm not finding this out. In this direction, however, I don't, there's nothing to worry because I already know what is FAC. So P, I'm taking upwards as positive, positive plus P minus FAB minus FAC, this is cos theta, this is theta, right? That is equal to 0. Now FAB is equal to P minus, what is FAC? We already got it. P by 2 cos theta, this is cos theta cancels, and this is P by 2. FAB is surprisingly P by 2 in tension. So this is there. It is not related to theta at all, right? So FAB does not have a theta term in this. It's already P by 2, P by 2. I mean, it's in tension. So FAC is P by 2 cos theta, and FBC is P by 2 cos theta. But this is compression, this is tension. So now, by now, I think you might have arrived to your answers, right? So what is the answer? So P by 2 cos theta in tension. So in tension, it should not be greater than 2. Let us say if it is in greater than 2, let us say it is equal to 2. 2p, that's what it is. So cos theta is equal to 1 by 4. This is one solution for this. And also P by 2 cos theta, which is in compression, it should not be what? It should not be P. In compression, the load should not be greater than P. So let us take it as equal to P. So cos theta is 1 by 2. So which one should I take? If my theta is cos theta is 1 by 2, what is theta? Theta is I think around 60 degrees. Okay. What if my cos theta is 1 by 4? I'll just try that also. Okay. For example, my cos theta is 1 by 4. Then what happens? P by 2 cos theta becomes P by 2 by 1 by 4, that is 2p. So compression is actually exceeding 2p, right? In compression, it should not exceed p. So cos theta cannot be 1 by 4. Okay. Cos theta is half, that is theta is 60. So my answer is C. Irrespective of it, again, irrespective of being cos theta as 60, what are the forces in tension? P by 2 times 1 by 2, that is P. They mention that it should not exceed 2p, but my maximum tensile forces are P only. That is fine, it is satisfied. What about the tension? So even if my cos theta, even if my theta is, let us say, 60 degrees, in compression it is P. That's what it is mentioned. So the theta should not be 60 degrees. If it is other than 60 degrees, either of the what do you call, either of the constraint or either of the whatever the condition will not be satisfying. So the theta should be 60 degrees. I hope this question is fine. Shall I go to the next question? I'll solve one more question actually. Um, the ones which I already have some calculations, I think that will be better. Maybe this one. What is FHI? Yeah, maybe we can solve one more question. Is it fine? It's already like 10 more minutes we have. Can we solve one more question, or you have any doubts, or shall we stop here and attend some doubts? Can someone speak? Okay. So fine. Anything is fine. Let us solve this question. This question is fine, right? We can solve this question now. I think I already have some solution for this. Maybe we can start solving this. So uh, what are the support reactions? First, support reactions. What are support reactions? So let us say this is Hg, and this is vertical in G, and this is Ha. So let us take moment about this point as 0. So for the moment due to external loads, sigma m equal to 0, that is equal to 5 times 6 plus 5 times 4 plus 5 times 2. So that's what I meant. This is 5 times 6, this is 5 times 4, this is 5 times 2. 2, 4 and 6. Okay. Uh, and again plus Hg times 3, that is equal to 0. 30, 20, 10 by 3, that is Hg, that is minus 60 by 3, that is minus 20. So Hg is actually in this direction, 20 kilonewtons. So if this is in this direction, there is no other force, so Ha should be in this direction at any cost. So Vg, we have 5, 5, 5, 15, so Vg should be upwards, that is 15 kilonewtons. So now this is fine, this is all right. So you can solve this truss in different two different methods again, method of joints and method of sections. So you can select either of it. So for example, if you want to, you can start from here. You can just keep on finding out what are the forces in this member and what are the forces in this member. So I'll just try to solve this joint, only this joint, and rest I hope you all can solve it. Okay. So let us say this is joint C, or this is, yeah, this is joint C, and yeah, this is D. So this is CD, and this is FCB, and this is FCE. I have an external force of 5 kilonewtons. Okay. So yeah, now what is FCE? FCE is again 5 kilonewtons. It is just I'm equilibrating the forces in y direction. Then FCD is equal to FCB. That is what it is. So it has to be tensile. So now I need let me take this pin also, D. Sorry. So this is D. So this is FDE, and this is FDC, and this is 5. Okay. So this is 2, and yeah, this is quite interesting. So you can see this is 2, this is 3. I mean what I mean is this is 3. So if what will be this? This should be 1.5, right? That height should be 1.5. So if this is 2, this is 1.5. So this theta should be 1.5 divided by 2 tan inverse. So let us say that is some theta, some theta. So this is theta. Now FDE sine theta, that is equal to 5. So FDE is 5 by sine theta. What is this hypotenuse? Hypotenuse is square root of 1.5 square by, sorry, plus 4. So that is 5 divided by, what is the sine theta is 1.5, 1.5 square plus 4. So this is FDE. What about FDC? FDE again cos theta plus FDC equal to 0. So FDE you already know from here, this equation. FDC is equal to minus 5 by 1.5 times whatever this is divided by cos theta. So you have FDC, you know what is FCB. So once you find this, you can find these things. You have this, you already have this, so you can find this and also this by taking the force equilibrium at this joint. Once you have this, and again this is quite, this is also direct, you know, you just take up in here, you have 15 support reaction which is upwards, you have 20 support reaction which is leftwards, so this will be directly 20, and you have this upwards, that means there should be tension coming in this member, that is 15. So this is known. What about this? So at this you have 15 coming in this direction and you have 15 in this direction, so you have um, two different unknowns. You can just find out by the force equilibrium. So I hope you can find this question. I can you can solve this question. You can also note down this question, and I'll also tell you the answer. Maybe you can uh, maybe you can try this question. I think I have solved this question. Yeah, for this question the answer is C. Okay, maybe you can solve this question. You can note down this. I'll wait for like 2 3 minutes. I'm sorry. Oh, sorry. Yeah. Sorry. Yeah. Determine the force in member AF and BE in the truss under the following loading conditions using the method of section. Anyways, that doesn't matter because I don't know which method you have used. Even if you are using method of section or method of joints, you will be getting the same answer. So yeah, find out the forces in member AF and BE for the given truss shown. Once you are done noting it down, if you have any questions or if you have some clarifications. No. See, span is at every, see, span at 4 meters means AB is 4 meters, BC is 4 meters, CD is 4 meters. Correct. Yeah. If that is 12, right? If this is completely 12, this is 3. So you have, this is 2 and this is 1. I mean, this length will be 1, this will be 2, and this will be 3. That is how you can, yeah, that is how you can find out the angle theta. Okay, you have noted it down. You have any you want some clarification? Yeah. Yes, it should be available actually. I think they will be sharing you. They will be sharing you this recorded session for you. Yeah, it should be available. Maybe I think first week I think they didn't share. I think maybe this week they'll be sharing. I guess.